Here's another simple question. We have three liquids A, B and C of same mass with their initial temperatures to be 12, 19 and 28 degrees Celsius respectively. When A and B are mixed, the final temperature comes out to be 16 degrees Celsius. When B and C are mixed, the final temperature comes out to be 23 degrees Celsius. Now we need to find out what is the final temperature, what will be the final temperature if A and C would have been mixed. So for solving this question, let us first write the equations for A and B mixture. When A and B were mixed, A was at 12 degrees Celsius initially and B was at 19 degrees Celsius initially, both were at mass M. Now always remember this, if you follow this method you will never get the wrong answer and you will never get confused. Whenever two liquids are mixed or two substances are mixed and you want to find out the final temperature, you always do one thing, you bring everything to one common state. So in this case we bring, let us take this for instance, let us bring the A plus B mixture to 12 degrees Celsius and see the net amount of heat involved. So when B comes to 12 degrees Celsius, heat is released, therefore we always write heat given, therefore heat given is equal to minus of, let the mass be M, into specific heat of B into delta T, that is 7. Since the heat is coming out of the system when it is when B is dropping from 19 degrees Celsius to 12 degrees Celsius, therefore we write this as negative sign. The heat given is negative, that means heat is coming out of the system. Now there is no heat coming out or heat going into the system overall, therefore this much amount of heat should be given back to the system. Therefore M into SB into 7 is equal to, at this moment of time the whole system A plus B mixture was at 12 degrees Celsius. Therefore we take this to final temperature, that is 16 degrees Celsius, to A plus B at 16 degrees Celsius. Therefore M into SB into 7 is equal to M into SA into 4 plus M into SB into 4 again. M gets cancelled to give 7SB is equal to 4SA plus 4SB, that is 3SB is equal to 4 times SA. So this is the first equation that we get. Similarly for B plus C mixture, initially B was at 19 degrees Celsius and C was at 28 degrees Celsius. The final temperature of the mixture comes out to be 23 degrees Celsius. If you do not like that method, you can also do it like this. The final temperature is 23 degrees Celsius, that means B has risen from 19 degrees Celsius to 23 degrees Celsius and C has fallen from 28 degrees Celsius to 23 degrees Celsius. So when B went from 19 to 23, it absorbed heat. When C fell from 28 to 23, it released heat. Now since no heat went into the system or came out of the system, therefore the heat released by C has been taken by B. Therefore we can write M into SB into 4, that is the rise in that is the heat absorbed by B, is equal to M into S of C into 5. We cancel M and M to get 4SB is equal to 5 times SC. Now for solving our question, that is what will happen to the A plus C mixture, we need the ratio of the relative, the ratio of the specific heats of A and C. Therefore we find that relation from here. We can write SB is equal to 4SA upon 3. We substitute this here to get 16 SA upon 3 is equal to 5 times SC, that is SA is equal to 15 upon 16 times SC. So we keep in mind this relation. For the A plus C mixture, initial temperature of A was 12 degrees Celsius. The initial temperature of C was 28 degrees Celsius. Let the final temperature of the system be T degrees Celsius. Therefore, the amount of heat absorbed by A is equal to M into SA into T minus 12. This is equal to the amount of heat lost by C, that is equal to m into SC into 28 minus T. Since T is between 12 and 28, we cancel m and m. Now SA is equal to 15 SC by 16, we write it here. 15 times SC upon 16. SC cancels to give us 15 upon 16 into T minus 12 is equal to 28 minus T. Therefore, from here we get 31 T upon 16 is equal to 28 minus 28 plus, this is T minus 12. Therefore, we get 28 plus 15 into 12 upon 16. On solving this equation, we get the value of T to be 20.3 degrees Celsius. So, final answer for the final temperature of the A plus C mixture comes out to be 20.3 degrees Celsius.